What is the most intelligent living species on the planet? Most people would probably say humans. After all, we've created technology that's revolutionized our lives, developed complex languages to communicate, and invented art, medicine, science. Our ability to problem solve, create tools, and change our environment seems like a clear indicator of superiority, right? But what if I told you that intelligence doesn't always look like human intelligence? What if intelligence is not about who's better, but about who is most suited to their environment? My name's Anique, and I'm an animal rights enthusiast, a plant lover, and an advocate for fungi. I've spent years researching how different species, including animals, plants, and fungi, interact with their environments. I'm also a proud dog owner. I have 2 dogs, Saber, a blue Doberman, and Sunset, a miniature dachshund puppy. Saber is almost 3 years old, well-trained and extremely intuitive, while Sunset, at nearly 1 year, let's say she's still learning the ropes of the world. As a pet owner, I've come to realize that dogs are much smarter than most people actually give them credit for. But intelligence doesn't have to be defined only by problem solving or language. It can look very different for different species. And I think it's important to recognize that other life forms, animals, plants, and fungi, are intelligent in their own unique ways. In fact, the way we understand intelligence is often limited by our own human biases. We tend to anthropomorphize or attribute human characteristics like reasoning or language to other beings. But what if intelligence isn't a one-size-fits-all concept? What if intelligence is simply a matter of how well a species adapts and thrives in its environment? If we look beyond the conventional definition of intelligence, which is the ability to acquire and apply knowledge and skills, and consider the diversity of life forms on Earth, we start to see that intelligence takes many forms. Human intelligence is not superior to that of other life forms, it's just different. From the complex communication systems of trees to the problem-solving abilities of cephalopods, intelligence exists in forms we may not fully understand. Today, I want to show you that intelligence isn't just about what humans are good at. It's about recognizing that all species, humans included, are part of an incredibly intricate web of intelligence. This includes animals, plants, and fungi, which use unique methods to survive, communicate, and thrive in their own environments. Let's begin with an incredible example of animal intelligence: cephalopods. These animals, octopuses, squids, and cuttlefish, are masters of camouflage. They can change their color and texture to blend into their surroundings, making them almost completely invisible to predators and prey. This ability isn't just for protection, it's also a tool for communication and mating. Roger Hanlon is a senior scientist at the Marine Biological Laboratory in Woods Hole, Massachusetts. He has spent decades studying the behavior of these remarkable creatures. Hanlon's research on cephalopods, particularly the octopus and the cuttlefish, has shown that their camouflage abilities are incredibly advanced and highly controlled. The chromatophores, or the pigment cells on their skin, allows them to change not only their color, but also their texture. Not the optical illusion of texture, but actual texture of their skin by creating bumps and ridges. This gives them a near magic ability to blend into almost any environment. But cephalopods don't just change to hide from predators, they also use their skin to communicate with other cephalopods. They can signal aggression, submission, or mating readiness through color changes. This kind of behavioral intelligence is deeply sophisticated. In fact, some studies suggest that octopuses can even manipulate objects and use tools to solve problems, a level of cognitive sophistication that places them among the most intelligent animals on Earth. Dr. Hanlon's work illustrates that cephalopods are not only highly adaptable in their appearance, but also capable of problem solving, a trait we typically associate with human intelligence. For example, there was one study an octopus was observed using a coconut shell to build a shelter. The octopus used its intelligence to understand the coconut's shape and how it could use it for protection, essentially showing tool use and planning. These abilities might not align with human intelligence, but they reflect a different kind of intelligence, one adapted to survival in a very specific environment. Additionally, Hanlon's research emphasizes that adaptive intelligence of cephalopods goes beyond survival. It extends into their social behaviors. For instance, cuttlefish use their camouflage skills to not only hide, but to engage in complex social signaling. They change color when courting mates, and they use intricate patterns and hues to attract attention. This adds an entirely new layer to the definition of intelligence, suggesting that complex, nonverbal communication should be recognized as a sophisticated cognitive ability. Now, let's turn to dogs. We often call them man's best friend, but their intelligence is far more complex than we usually give them credit for. As I mentioned, I have two dogs, Saber and Sunset, and I've spent a lot of time learning about how they communicate and how they think. Dogs are known for their ability to connect with humans on an emotional level. They're not only attuned to our moods, but they also rely on a highly developed sense of smell to interpret their environment and communicate with each other. Dogs have approximately 300 million olfactory receptors in their noses, compared to just 6 million in humans. This makes their sense of smell 20 to 100,000 times more powerful than ours. But their sense of smell isn't just for finding food or tracking objects. Dogs can detect emotional states through scent. For example, they can smell stress hormones like cortisol that are emitted when we're anxious or afraid. Studies have shown that dogs can sense their owner's emotions even if they don't see the physical signs. They know when you're upset, and they often act comfortingly to help. This demonstrates an emotional intelligence that's complex and deep. There was actually one study conducted by animal cognition expert Dr. Stanley Coren that showed that dogs can interpret human gestures and emotions with remarkable accuracy. The study found that dogs can understand facial expressions and often respond empathetically to their human companions. For example, a dog may nuzzle you when you're sad or excitedly greet you when you're happy. However, dogs also have their own form of social intelligence. They communicate with each other using body language, facial expressions, and their sense of smell. They don't need human words to convey emotions or understand each other. In fact, dogs are exceptional at reading our body language, recognizing the slightest shift in tone or movement. Their ability to learn from nonverbal cues shows a deep understanding of human behavior. It's as if they've developed a unique shared language with us, one that transcends worlds. It's a communication system built on empathy, trust, and mutual understanding. Dogs display cognitive flexibility, a key component of intelligence. Research has shown that dogs can adapt to new situations and solve problems in very innovative ways. For example, there are dogs that can be trained to perform tasks like guiding the blind, detecting medical conditions such as seizures or low blood sugar, and even acting as emotional support animals. These skills show how adaptable and intelligent dogs can be, demonstrating an interdependence that transcends basic obedience. Finally, I want to talk about plants and fungi, two life forms that most people don't associate with intelligence, even though they are constantly interacting with their environment in highly intelligent ways. For instance, did you know plants can communicate with each other through an underground network of fungi known as mycelium? Paul Stamets, a renowned mycologist, has dedicated much of his life to studying the intricate relationship between fungi and plants. He discovered that mycelium, the underground network of fungal filaments, acts as a form of communication between the plants. It connects trees and plants, allowing them to share nutrients and even information with each other. His research has shown that when a tree is under threat from other pests, it can send chemical signals through the mycelium to warn other trees in the vicinity. Similarly, when a tree is in distress, such as during a drought, it can send nutrients through this underground network to help other trees survive. The wood wide web, as it's sometimes called, illustrates an entirely different form of intelligence. One that relies cooperatively with communication rather than competition. What's truly fascinating is that this system also supports a shared intelligence in which plants work together for mutual benefit. One study found that trees in a forest use the mycelium to transfer carbon, nitrogen, and water to other trees in need. It's a beautiful example of interdependence, a form of intelligence that ensures the survival of the entire forest community. Plants also exhibit intelligence in the way that they adapt to environmental changes. They're capable of decision-making based on sensory input, such as changes in light, temperature, and moisture. Studies have shown that plants can even remember certain environmental conditions and adapt their growth strategies over time. For example, plants can learn to avoid predators or maximize exposure to sunlight through rapid growth adjustments. In addition, fungi, like mycelium, have shown problem-solving abilities. They can detect the presence of obstacles in their environment and change growth patterns accordingly, displaying a level of spatial awareness and decision-making that mirrors cognitive flexibility in animals. So, intelligence is not a single human-centered concept. Intelligence is a spectrum. I invite you to consider this. What if intelligence isn't a matter of who's better or who's smarter, but rather a matter of who is most suited to their environment and purpose? Every species has evolved to meet the challenges of their surroundings, using their own unique set of abilities and intelligence. When we start to think of intelligence in this way, we begin to appreciate the diversity of life on Earth. The cephalopods can change their skin to survive and communicate. Dogs can sense emotions and navigate the world through smell. Plants and fungi communicate silently underground, ensuring the survival of their own communities. All of these are different expressions of intelligence. And just because they don't look like our intelligence does not make them any less valuable. So, the next time you're out for a walk with your dog, or you see a mushroom sprouting out after a rainstorm, or maybe you catch a sight of an octopus changing colors at the aquarium, remember this: the world is full of intelligence, and it's all around us in forms we might not always recognize. Intelligence is not about who's the smartest, but about appreciating the diversity of the intelligence that exists. And perhaps, just maybe, we can all learn a little something from the way the world's creatures experience it. Thank you for letting me share this perspective with you today. I hope it inspires you to look at the world and all of its creatures a little differently, from a place of curiosity, compassion, and respect. Thank you so much for listening.